Today let's see what dimensionality reduction is in machine learning. So for giving you a pretense of why we are getting into dimensionality reduction, consider this as an example. Suppose you have a data set where there are 10,000 columns, okay, and now there are 10,000 columns and you want to fit a good machine learning architecture. Suppose you want to build a neural network for that, or you want to use XGBoost on that. So what will happen if you just use all the 10,000 columns and you have suppose 10 million rows as well? It will take a lot of time, it will be computationally expensive, and the next thing is the results most won't be that good in most of the cases. Why? Because of the curse of dimensionality. So what happens is, when we have a lot of dimensions, where we have a lot of features, what happens is that we get a lot of unwanted data as well, which does not give the model the right direction to go in, but it disturbs the model. It is kind of the noise. So for explaining noise, I'll tell noise is not music. No one likes noise, it just irritates you. So it's similar in the case of machine learning models as well. So data which is not useful is redundant data, but still my machine learning model is considering the data to get something out of it, but instead of getting something useful, it is going into the opposite direction. So that is why its performance is also not the optimum. That is why we need dimensionality reduction techniques like PCA. So for getting into the depths of that, I'll take another video, but just to give you an intuition about how dimensionality reduction works is that they try to see which dimensions are independent of each other, and then they reduce the dimensions accordingly. Okay, so this is how dimensionality reduction works. I hope you like the video. Comment, share and subscribe to our channel. Thank you.